Hi, I'm Raymond Lin, and this is Strategic Math. In our fourth lecture, we're going to continue our third lecture and talk about how we will use those initiatives to solve our problems. Today, we'll use the initiatives that we've talked about and introduce new ones to solve the four questions that we're going to talk about. Let's begin. First, we'll review the intuitions that we have talked about in our last lecture. The first one is that we have talked about the side-to-side intuition that will happen in squares. We've also talked about the symmetry in triangles. So let's look at our today's first question. It asks to solve for the angle of x in this diagram. You can pause the video and solve the question by yourself. Well, to answer this question, we'll have to use the intuitions that we have talked about with a bit of creativity. First, notice that these two lines have the same length. Notice this triangle. Haven't you think of the intuition called side-to-side? We can rotate and move this triangle to stick to the other side. But these triangle and the question overlap. We don't know how to solve the problem. So here's a bit of twist. Let's turn the triangle. Then we can use the other set of relationship that these two lengths are the same. And we can form another new triangle that is congruent. This means that these two angles will be x. And because these three triangles are essentially the same, we have an equilateral triangle. In this case, this means that 2x equals to 60 and x equals to 30. And this is how we solve question 1. So now let's look at the question again. We have used our first intuition side by side to solve the problem. How about our second intuition? Well, if we want to use our second intuition to solve the problem, you'll need a bit of try and error. So let me tell you where the symmetry axis needs to be. It needs to be here, on AC. So let's now draw the symmetry. We'll connect the lines. We find that the angle CEA will be easily 135 degrees. Notice one thing. The angle ABC plus 2 times the angle CEA will be equal to 360 degrees. This means that B is the circumcenter of the triangle AEC. So let's go through it backwards. We'll draw the circumcenter of the triangle AEC called B. We find that AB equals to EB equals to CB. We can easily solve that the angle EAC will be equal to 60 minus 45 equals to 15. This means that the angle X will be equal to 30 degrees. So we've again solved the problem, but this time we used our second intuition. So let's think about what is the key step to making this question solvable. Well, we need numbers to solve this question. The most important step in this solution is this equilateral triangle. Notice that in the previous solution, there's also an equilateral triangle present in the diagram. So now we developed our third intuition, which is equilateral triangle. And we'll now use our third intuition plus the previous intuition to solve the questions that we're going to present later on. We'll now look at question 2. It asks to solve for x in this diagram. Well, we'll now use our third intuition to solve this question. We'll draw an equilateral triangle. We'll connect the lines, and we can easily see that there's a symmetry axis present in this diagram. This means that this angle will also be x, and these angles will be 20 degrees. This means that this angle is 40 degrees, and we can easily solve for x. X equals to 180 minus 40 divided by 2 minus 60, which equals to 10. And this is how we solve our second question. Now let's look at question 3. It asks to solve for x in the diagram. I'll encourage you to give yourself more time to think about this problem, because this problem is much trickier. Well then, let's see how we will solve our third question. Well, the tricky thing about this question is that the equilateral triangle is not either on AB or AC. It is on AB. Well, now you can notice something. The angle EDB will be equal to 90 minus x. The angle BD will be equal to 2x. Haven't you noticed yet? Because the angle BD equals to 2 times the angle BAD, this means that E is the circumcenter of the triangle ADB. So this is what we've got so far. But now we'll need to use our second intuition to solve the problem. Because AB equals to AC, we'll draw the symmetry axis here. We'll then connect the lines and make the same triangle. This means that the angle FAC will also be equal to x. Notice that the triangle BED will be congruent with the triangle ADE. This means that the angle DAF will be equal to 2x. This means that in this question 4x equals to 40 and x equals to 10. And this is how we solve our third question. We'll now look at our last question for today, our question 4. It says that BD equals to CD, AB equals to 4, and AC equals to 5. 2 times the angle BAD equals to the angle BDC, and it asks us to solve for the area of the triangle BAD. Well, to solve this question, we'll need to go back on our first intuition. First, we'll express our conditions using algebraic forms. Let's say BAD equals to x and DBC equals to y. Because DB equals to DC, we can look at the triangle ADC. We'll rotate the triangle, and then we'll connect the lines. You can easily see that the angle ADE will still be 2x. This means that these two triangles are similar, and DAE equals to y. Notice that in the triangle BDC, 2x plus 2y equals to 180. This means that x plus y equals to 90 degrees. And you can see that the angle BAE equals to 90 degrees. So let's redraw the diagram to this. Remember that these two triangles are similar. This means that AD equals to B. To solve for the area BAD, it will be equal to 1/2 times AB, which is 4, and times the height from B to AB, which is 1/2 of AE. This means that the answer for this question is 3. And this is how we solve our fourth problem. So let us go over the intuitions that we have said throughout these 2 lectures. First, side to side. Second, symmetry. And third, equilateral triangle. And that's about it. We'll see you soon on our 5th lecture.